as Matt mentioned, I'm Alex Balashov, and I'm here to represent the Kamailio project this year. I'm aware that this isn't Kamailio World. This is AstriCon. And to that end, I want to give you a couple of simple takeaways and simple ideas about the relationship between Kamailio and Asterisk and the way that that has evolved over the last, let's say, 10 years, plus or minus, because a lot has changed philosophically about the project then. And with that in mind, what is Kamailio? Most of you probably have some idea, but Kamailio is kind of a programmable grab bag of different things. It has an internal SIP registrar, but at the core, it's a SIP proxy. And it's, of course, acquired quite a lot of other tentacles as well. But in essence, I think the traditional understanding of Kamailio within this community is that Kamailio is the kind of routing fabric you go to once you have outgrown more or less what a single asterisk box can do. And so the low-hanging fruit applications of that are load balancers, centralized registrars, various security functions that front-end asterisk, things like that. But basically, Kamailio is primarily of interest to service providers. There's not going to be a lot of kind of retail uses of asterisk that are going to call for Kamailio. And maybe it'll surprise you, maybe it won't, but I spend quite a bit of time talking people out of using Kamailio because given its eclecticism, there are understandable misconceptions about what it does and doesn't do. But I think that the metaphor of a SIP proxy and Kamailio in particular as the network, the layer 1, layer 2 network that connects servers is probably relatively intact in terms of what Kamailio does. Once you have a need to steer traffic in and out of a service provider core, whether it's delivering applications, PBX services, some other real-time communication service, things like that, that's generally where Kamailio would come about. And again, I think load balancer is probably by far the most common application you typically see, and we usually talk about Kamailio as a means of scaling out asterisk. There's actually been a lot of convergence between things that Kamailio does and things that asterisk is capable of doing in an increasingly performant way. So I think that some of the traditional arguments for scaling up with Kamailio, handling more users with Kamailio, having more call capacity with Kamailio are a little bit antiquated, which is not to say that they're inappropriate. Anytime that you need to horizontally scale asterisk, I think Kamailio is an appropriate way to invest in that desire. But the amount of things that asterisk does nowadays and does very well with its overhauled SIPs channel driver and many other core improvements is just very, very different. So in terms of what is new in Kamailio over the last 10 years, I'm not going to read you the change log or talk about a lot of things that are only of esoteric interest to Kamailio wonks. I'm going to try to give you a couple of relatively small and actionable takeaways. Kamailio started out as SIPExpress router in the early 2000s. I think the first commit was pushed in 2001. It kind of grew up in tandem with asterisk, but with very different intentions. And at the time, the decision made sense to develop essentially an embedded domain-specific scripting language to drive the kind of thing that it is. I think without wanting to impute a lot of read a lot of motives into the tea leaves of the developers of SER at the time, I think teleologically, if you look at the shape of SER in the early mid 2000s, you could reasonably conclude that it was meant to do a relatively narrow set of things, and to do them not to serve as some sort of large-scale clearinghouse for SIP traffic. I think you can make that conclusion by looking at the way it was simultaneously programmable and not particularly flexible. I think it wasn't until 2009 or so that Kamailio 1.5 actually acquired a first-rate way to generically query databases, if that gives you any idea. So, whereas Asterisk was very, API and connector heavy from the get-go, SCR was kind of a hard-coded black box. And then in the 2010s, there was kind of a cultural moment of trying to make the Kamailio route script into something bigger, something that more closely resembles a general purpose programming runtime with a lot of primitives and standard library functions. And that's all very impressive. And I think now there's a little bit of a realization that, well, there's some things that there's limits to that approach. There's some things it does well and some things it's just destined to perennially suck at. But, in concert with that kind of movement, those kinds of currents, I think a lot has been invested from the project into alternative ways of driving its configuration using programming languages that are familiar to you. This obviously improves testability. It improves the ability to silo your development talent and leave your Python programmers to write business logic and do Pythonic things without getting overly idiosyncratic. There's obviously an awareness that Kamailio is increasingly deployed in virtual and container environments. And I think that awareness extends beyond just service provider infrastructure and also into the realm of CI/CD systems that use containers to automate, to drive integration and end-to-end testing. And so Kamailio has more options now that are, whose fronds kind of tend that way. There's some new testing tools in the ecosystem, and I'm thinking of Daniel's excellent SIPExer tool, which we'll discuss a little bit. More asynchronous processing options, which I'll speak to a little bit later. But I think the major theme, if I can just impress one idea upon you, is more interfaces and connectors to outside systems, which is not historically a strength of Kamailio. Partly that's design decisions, partly just lack of implementations. Part of it is its concurrency model. It hasn't historically been great at talking to other services in a service-oriented architecture context, and that has been very much changing. And then, of course, we're in a very mobile-first world now, and there are some interesting capabilities Kamailio's been festooned with there that make for a fairly common use case, actually, for those who implement it. So, just to touch on the last point on this slide, one of the limitations that Kamailio historically has had in a service provider environment is in order to make even relatively trivial config changes, you have to restart it. And some of the new config language and API options that have come about will actually allow you to have a reasonably hot reloadable config. Now, there's limits to that, can't change everything that way, but you can change an awful lot of things, especially where business logic is concerned. So the Kamailio vocabulary for alternative first-class config languages is Kemi. What exactly it stands for actually escapes me just this moment. But out of the box, it supports writing the Kamailio config in JavaScript, Lua, both Pythons, Ruby, and something called Squirrel. Obviously, aside from the fact that you can write Kamailio config in your native language of choice, you also have access to the broader programming runtime and capabilities of that language interpreter. So the way that it basically works is that Kamailio loads, it executes an embedded interpreter of that language and delegates message processing functions to it. So just to give a JavaScript example of what that looks like in practice, on the left side you have traditional Kamailio route script, which is a C-like domain-specific language, as I mentioned. And on the right side you have the Python version of not identical logic by any means, but it should give you some idea of what the API surface of it looks like. So it does more or less expose Kamailio config route primitives into the language namespace on a kind of one-to-one basis. And so with that in mind, kind of as part and parcel of this increasingly compartmentalized, modularized approach, there are more options to allow you to dynamically configure Kamailio externally, bootstrap it inside of container entry points and things like that. Again, useful not just in your production infrastructure, but also very critically for for testability. Now, I'm not going to go through all of these. It's simply to say that the mechanisms by which you can pass various kinds of service discovery relevant constants into Kamailio, things like ephemeral IP addresses from dynamically instantiated instances, constants related, to macros inside the config that enable certain functions, has expanded. It's become easier to create a cloud-ready container that has, the right kind of interface to the outside world, to where your orchestrator can whisper into its ear. There is a new tool that I think caters to an underserved market need in the SIP testing tooling ecosystem. I think most of us are familiar with SIP-P. And SIP-P remains, I think, a first-class choice for I suppose, load testing. But, it's interactive. It doesn't lend itself to machine processable output or embedded applications. And this is where SIPExer is nice. So on the one hand, SIPExer is a fully in-the-box SIP UA and is reasonably high level in that sense. On the other hand, you can change a lot of options in terms of how the SIP messaging is constructed. So it really serves that middle tier of testing abstraction, that middle stratum that's always been a little bit lacking in the open source ecosystem very well. So just to give an idea of how we use it, for example, in the top right, you have a typical command line invocation of SIPExer to generate an invite. And as you can see, there are loads of options for how to build the contact header, how to build the via header, the values to populate in many essential SIP requests. And so we wrote a Python wrapper around that, and we used that out of PyTest tests and test fixtures. And one of the most helpful things about SIPExer from a testing perspective is that it returns the SIP status code that it got back on its call attempt as a return value to the shell. So it's relatively easy to assert that if you're expecting a 503 service unavailable, that's what you got in the context of test automation. So without getting too much into the weeds, Kamailio's concurrency model, the way that it handles requests at such a high speed in parallel, it's the pre-forked worker process model, and that has certain trade-offs. It's good for some things and not very good for others. But in essence, Kamailio forks a limited number of child processes that, a reasonable baseline for how many is about one per available CPU core. And obviously then you tune that depending on the nature of your workload. So if you have a primarily computational workload, then you really don't have many child processes. And if you have a very database driven or other IO bound workload, you might have quite a lot. And so you can think of this as like a massive 8-lane highway where you only really have about 8 lanes. You don't have 6,400 lanes. You have about 8. And it works really, really well when everybody is staying in their lane and doesn't change lanes, doesn't cut anybody off, doesn't have any motives to enter or exit. They just keep flowing in their lane. And this is one of the reasons why Kamailio performs so admirably in its infrastructure role. But complications do arise, especially when you start talking to other services. And so Kamailio has for a very long time now had various means of packaging the idea that we're going to take a SIP transaction shell that is created around a SIP request. We're going to suspend it, put it on ice for a little while, awake it in a different set of worker processes, and thus get the relatively latent operation that might be happening out of the critical path, out of the main code path through which SIP messages pass in the core worker pool. But what I'm trying to drive home with this slide is not really a laborious disquisition of what exactly those are, only to say that they've evolved a lot. A lot of the packaging of the underlying, worker process and worker pool management has become more high level, and so the user ergonomics, especially the casual user ergonomics of that, are better. And so when I think from a end user use case perspective, the underlying takeaway is that you can do more talking to HTTP APIs, databases, message brokers, things like that. You have more options for dealing with the performance impact of that and ways to manage that kind of workload in Kamailio. Again, the basic capability, the kind of low-level asynchronous task primitives have been around for a long time. There's been some new packaging for worker process groups and things like that that just make it easier to get started and have Kamailio manage the lower level internals for you. There are a lot more connectors to outside systems. This is just a small sampling of what's available. A lot of these are contributed by third parties, of course. But again, going back to the OpenSARE/SARE/Kamailio of the 2000s, I think at one time there was a perception of like, well, apart from its built-in modules and the database schemas that back them to do things like registration and presence, this thing can't really talk to other things well. And there was a bit of an epiphany about that that's, I think, started with talking to RDBMs and spread eventually to, a cloud-oriented and service-oriented architecture world. And so the Kamailio of today is not the Kamailio of 10 years ago in first and foremost the sense, like the sheer number of things that it can talk to. It's got a WebSocket client now. It has its own stir-shaken implementation. It's got HTTP clients. It has the ability to send and receive arbitrary data on the wire that isn't just SIP and doesn't have to be jammed through the SIP parser. It can talk to various kinds of message brokers, do things that are prerequisite to talking to other APIs and services like generating and signing JSON web tokens. Construct JSON inside the config route script. And so I think that's probably the most monumental shift in the project overall, and it's kind of general tenor. No, it can't talk to everything you might want it to talk to, but it can talk to a lot of other things that can talk to those things. And so I think the opportunities for middleware, integration, and assembly into a larger whole have really increased at a technical level. And the support for that mode of interaction went gradually from being a bit stilted and not very ergonomic to rather first class, as Kamailio config script goes anyway. I think something else that gets a lot of press these days is mobile push notifications, and Kamailio has absorbed this need in a relatively elegant way. So if you have some sort of soft phone or communications application on iOS or Android, I think most of you know that that application or even its service stub on Android doesn't really run in the background. Instead, it's essentially put to sleep, and there's a proprietary mechanism for kicking it awake. So that means that if you are offering a mobile app-based communications product, you have to handle things very, very differently. You might be using Kamailio's registrar, but you have to basically presume, for reasons of roaming and carrier grade NAT and the internal architecture of mobile networks that every registration you receive, no matter how short-lived, is sort of ipso facto invalid. Kind of like what you get from browsers. And so there's a workflow where we get an invite, we're getting a call to your mobile application. I see that you're registered, albeit the registration that you made 2 minutes ago is no longer really of interest to me. So I'm going to just sit on that invite, use the Google or Apple push APIs to poke the mobile endpoint. That mobile endpoint immediately re-registers, and when it does, then Kamailio sort of magically forks the request to that new destination. There's a module in Kamailio called tsilo, and it has done a pretty marvelous job of abstracting that functionality while still giving you a lot of low-level call control. So I think the overall capacity to use Kamailio as part of an integrated service provider core to do all kinds of things and talk to all kinds of other systems is probably the main thing that has evolved a great deal. Otherwise, the project has had a very stable and performant core with relatively few kind of methodological changes over time. I mean, I think the fact that it's a stable and known quantity and mostly just runs maybe sounds a little braggadocious. It's not perfect, and it's certainly not certifiably bug-free, but it's probably one of the most famous things about it. It's a rather reliable and robust piece of infrastructure. But under the hood, you've got a lot more ways to integrate it with other services and de-silo some of the, the institutional memory and the knowledge that you have around Kamailio. So in practice, all these connectors aren't just about how you organize the technical schema of your infrastructure. They're also very much about boundaries between teams and organizations and interfaces and skill sets and who you can hire off the street to do this stuff, and will they also be able to do that other thing. And that whole equation has also changed as a result of these connectors, which again, at a certain scale in the service provider world, actually starts to become quite important. So that's the main message that I seek to impart. I think that's it. With that said, I will be happy to take any questions.
You can call me Matt temporarily. Hi, I'm Matt. Any questions, and I will make my way towards you. I do urge you to ask questions of Mr. Balashov. He is very knowledgeable, as has been mentioned previously. I'm sure he will answer any relevant questions towards SIP, Kamailio, or even cycling. We will also answer questions relating to that. I just voluntold him for that. I will run towards you. Actually, I'll shuffle.
Sorry, it has been a few years, but what is the what's the preferred integration then with Asterisk currently? Can I run Kamailio on the same box and read my PJ-SIP comp files and parse it well enough? How much connector do I need? Or would it be better to just pull it out of the database still for that purpose?
Well, I don't want to give you a cop-out answer. Much depends on many things. I think I could say a couple things. So there's I think a presumption in your question that your users are ultimately calling in and out of Asterisk as extensions, as kind of canonically as we understand it. When you do that at a sufficiently large scale, you have two basic directions you can go. You can either use Kamailio as a centralized aggregated registrar where your extensions register to instead, or you can relay those registrations upstream to one or more Asterisk servers. And why you might want to do one or the other, greatly depends on fairly low-level SIP arcana. But depending on which way you go, your Kamailio config might end up being quite simple or quite complex. But I think in terms of how the traffic actually gets to the Asterisk servers, there's a module in Kamailio called Dispatcher. It's load balancer module. And I mean, the stock config is almost primed for that kind of use case. So I think a very typical setup that involves scaling out Asterisk horizontally would be to round robin calls into a pool of Asterisk servers and to use Kamailio as a centralized registrar and just have the Asterisk host to reach your extensions, your registrant endpoints through it. There's also a big change in the way that redundancy is done for the registrar if you go that route. It used to be that it indeed had to be persisted into a database and database backed, whether in real time or sort of on a delay. And this has been, it certainly hasn't been replaced, but it has been augmented by a internal network replication system that Kamailio has called DMQ, which can share all kinds of messages. It's essentially its own kind of little pub sub broker message bus. And so it is now possible to have a large-scale registrar that replicates itself to other registrar instances without relying on a database. I know that was kind of a hodgepodge, but hopefully it hit on some of your points.
Any additional questions for Mr. Balashov? No? I'm sure he'll be around, so if you do have questions, you can always run into him and then ask him immediately without introducing yourselves. I'm sure he'll find that quite amusing. Otherwise, the next presentation is actually at 10:30, so we'll take a short break now. Well, longer than probably could be considered short. As well, please take the time to talk to the people around you too. If you have questions for myself, Lauren, who's right there looking at his phone, about free PBX, feel free to come on over. Asterisk team is here. I just voluntold them. And like I said, next presentation is at 10:30, and that'll be about free PBX. So I'll see you then.